and that would give you that point. Let's do some of this grunt work somewhere else, because I don't want to make it all dirty here. Oh, I gotta remember that one. That's tough for my old age. Negative 1.25 plus 1.75 times x minus 1.5. I gotta set that equal to 0. That would mean that 1.75 times x minus 1.5 is equal to positive 1.25, which would mean that x minus 1.5 is equal to 1.25 divided by 1.75. That would mean that x is equal to 1.5 plus 1.25 over 1.75, right? And let's bring up our little machine here. Let's see if we can crank that one out. 1.5 plus 1.25 divided by 1.75. Get an approximate answer. Boom. 2.21. X is equal to 2.21. Well, approximately. That, my friends, what does that do with the picture? That tells me this one right here. 2.21 is supposed to be a better solution. Now what? Now what? Now Newton says, hey, keep doing that. You're doing good, buddy. Let's roll with that. You come up to this point again, and at that point, right at this point here, now we want to start the process all over again. I want to find the tangent line for that one right there at that point. I'll make this one in yellow just for fun. If I find the tangent line right at that point, guess what it's going to do for me? It's going to point me, hey, go that way, buddy. The solution is that way. And I'll get even closer. And then I'll and then I'll do it over and over and over and over again. It's a beautiful process. Let's do it. Talk is cheap. So at this point, what would the equation be? Well, the same as it's always been. At that point, my second line would be equal to f of 2.21 minus or plus f prime of 2.21 times x minus 2.21. Right? The same as it's always been. The equation of the tangent line is given by f at the point plus f prime at the point plus x minus the point. So I can figure that easily. Let's see. I got to plug in 2.21 into that equation. Let's bring back our little calculator here. We got to plug in 2.21. So P2x is equal to whatever I get there plus whatever I get there times x minus 2.21. Let's see, what do I get there? Let's go with 2. So I gotta clear this stuff. Clear. Okay, let's go with 3 minus 5 times parentheses 2.21, close the parentheses, plus open parentheses 2.21, close the parentheses, raise that to the third. See it? I'm plugging it in here. And what do I get? 2.24. Oh, 2.74, I'm sorry. 2.743, that goes right here. 2.743. 2.743. And then I go with this one. I need to figure out what that is. So I'm plugging it into that one now. Alright, so let's clear this. Man, this calculator makes me nervous. That plus, let me see, negative 5 plus 3 times, I gotta do 2.21, and then I gotta raise it to the second power. Check it. I'm plugging it into here, and you get equals 9.652. That would go here. 652. And then I just crank that out. No, I set it equal to 0 because now I got the equation of the line. That's going to point me in the right direction so long as I set it equal to 0. So let's take this one. Let's copy it. Let's put it here. Let's paste it. And let's solve this. We set it equal to 0. So 0 is equal to 2.743 plus 9.652 times x minus 2.21. So move this over, so I get negative 2.743 all over 9.652 is equal to x minus 2.21. So you get that x is equal to 2.21 minus 2.743 all over 9.652. Was that too fast? Well, rewind it then. I'm just kidding. Now what is that now? Oh my goodness. Let's bring back a little magic calculator here. Let me think. This part makes me nervous. 2.21 minus 2.763 divided by 9.652. Bam. I get 1924 1924 approximately. That's my x. What did we do? What does that mean on the picture? That means that our second approximation, this one right here, is 1924 approximately. That would be my third approximation, x3, right there. You could barely see it. And guess what I'm gonna do next? Oh, my buddy Newton, genius, Sir Isaac Newton, Mr. Sir Isaac Newton. Yeah. All right, let's do it again here. You don't always have to draw the pictures. You know, after a while you get the hang of it. Let me think. All I do is do this. So it's gonna go like this. Look. The next line will be equal to f of whatever that was, 1.924 plus f prime of 1.924 times x minus 1.924. Then I'm going to set that equal to 0, and that's going to give me f of 1.924 plus f prime of 1.924 times x minus 1.924. And the reason I'm setting it to 0 is because that sends me in the right way. Then I'm going to move this over to the other side. That's going to give me negative f of 1.924. Then I'm going to divide that by that, so it's going to give me f prime of 1.924, and that's going to be equal to x minus 1.924, and that's going to give me that, that's not enough room, x is equal to 1.924 minus f of 1.924 all over f prime of 1.924. See, after a while you start to learn the pattern. If you do it without committing to a particular number, you start to see the pattern. It's always the same thing. So after a while, you should make it your own, and you can come up with your own little algorithm to solve these. Well, everybody's done it already. It's pretty common. Everybody does this to get the next x. In fact, the formula. Well, I'll tell you more about it later. Anyways, let's do it. So we got to do 1.924, right? So I'm going to go. This is going to be equal to x equals 1.924 minus. I'm going to save a spot here for whatever I get when I plug it into f, and I'm going to save a spot down here for whatever I get when I plug it into f prime. Let's do the plug in 1.924. Alright, that's what I gotta do. So I bring back my calculator. 1.924. Let's clear this stuff. So I go 3 minus 5 times 1.924 plus 1.924 raised to the third. And what do I get? Whatever. 0.50. Alright, let me put that so I don't forget. 0.50. Okay. In fact, it's 0.50 02. Alright, now let's go back and do the other one. We gotta go into there with 1.924 plugged into that one. So here we go. So I clear this stuff. Clear. Then I go negative 5 plus 3 times 1.924 raised it to the. This is so much grunt work. I hate grunt work. I love the idea, but this grunt work, man, is killing my soul. Alright, 6.105. 6.105. And then I crank this out, and that's going to be my next x. What was this? X4, I think we're up to. So let's do it. me see, let me have some room here. I gotta plug this into there so I can figure out the next x. X is equal to, let's clear this, and I go with 1.924 menos 0.502 divided by 6.105. Bam. Oh, 1.841. No, 1.842. 1.842. That's my next x. So I found the equation line here. I found the next one. That one is x4 is 1.824. It's beautiful, isn't it? And then you can just keep going and on and on. Eventually, these numbers won't change that much because you're really, really, really close to the real thing. That, my friends, brought to you by the great El Grande, Mr. Sir Isaac Newton. All right, you just want to try one more? I'm kind of running out of gas, but I think we should do one more. And I want to practice this idea here of streamlining the process. Let me just pause this for a second. If you guys want to run, get a cup of coffee or something. Let's take a little tiny break. Alright, so let's take a look at this one. If you look at it, it's not even a polynomial. It's a polynomial mixed with a trigonometric function. It's not that easy to solve this using the old techniques, but of course Newton's got some good stuff here. We've got a couple solutions here. By the way, many of these have many solutions. If you want to get a different one, it all depends on your first starting point, your x1. If you choose one that's close to here, that will point me in this direction. If you pick one around here, it'll take me into this direction, because I'll get tangent slopes and it'll point me in the right way. Every once in a while you choose something that's really not helpful. If I chose this one, 1.5 or whatever that number is, it points me into La La Land over there. It won't even intersect the x-axis, so that won't have any solutions. So just based on the graphical, whatever characteristics the function has, some x values are not good. Some of them will point you outside the domain of the function. So the x1 is incredibly important. Your choice of x1 is incredibly important. For example, here, 2.5 would be a good choice for x1, or 3.5. You could plug it into the function there and see if it's positive. You see it's a positive. You plug it in there, you see it's negative. So somewhere between there, it had to go through being equal to 0. That's the sort of thing that you want to reason through to pick your first starting point, or you want to do your first and second derivative sketches to see, roughly speaking, where the roots are. Okay, once you've chosen one, let's see if we can streamline the process just a little bit. Let me see. I want to streamline the process. I'll use this generic graph to see if I can streamline the process. So I pick this as x1. I'll call it x1. My first graph my first tangent line would be this one, and the equation would be given by something like this. P1 of x is equal to f of x1 plus f prime of x1. Tell me if you've seen this before. You've seen it a million times. You set it equal to 0 to lead you to x2. That's what points you to x2. You set it equal to 0. So you get that f of x1 plus f prime of x1 times x minus x1 is equal to 0. Then you move this over to the other side, f of x1. Then you would divide by that. That would give you f prime of x1. This would be negative. Then you add the x1. This was x minus x1. That tells you that x is equal to x1 minus f of x1 all over f prime of x1. And that would give you your x2. This would be your x2. This is x1, by the way. The trick is or the idea here is to try to generalize it. What do you think x3 would be? Well, x3 would be x2 minus f of x2 all over f prime of x2. Yeah, what do you think x4 would be? x4, the next x, would be the previous one minus f at the previous one divided by f prime at the previous one. And on and on and on and on. The 100th approximation would be the 99th minus f of evaluated at the 99th over f prime evaluated at the 99th. Okay, in fact, in general, the n plus 1, the next term, would be given by the previous one minus f at the previous one over f prime of xn. This is what most textbooks show you. It's a famous formula. It comes from finding tangent lines, setting it equals 0, pointing you in the right way. When it's all done and polished up, this is what it looks like. This is what most people do on a daily basis. I'm kidding. They probably program some software to do it. They don't really do it, but the idea is beautiful, so that's why we're studying. We're celebrating ideas. This is a class about ideas, timeless ideas. Anyways, why don't we try this streamlined process here, and I think this will be our last example. So I'm going to pick a good choice for x1. I hope it's a good choice. Sometimes you don't know. By the way, sometimes you get these crazy choices that, you know, if the function looks like this, it could be pointing you over here, and then this one could point you back there. You could go into a cycle where it doesn't really end. So I'm telling you, the first choice of x1 is incredibly important. Use your common sense to pick a good one. So I put x1 is equal to 4. Then I already know x2 would be equal to 4 minus f of 4 all over f prime of 4. So this kind of gets old doing this stuff. So I put it on some software. You can choose your software, calculator, whatever you want to streamline the process. Unless you like grunt work, be my guest. So I put it on here. I put x. I had my function here. I don't know if you guys can see it. Let me see if I can zoom you in there. 300. Will that be 300%? This is just a standard spreadsheet. So I put my x value here. You see x value here. I put my function. I took the derivative. That would give you negative 2x plus 3 plus cosine x. And I put my next x. My next is always x minus f over f of prime of x. And so the function would look like this. I don't know if you can see it. It's up there. Can you guys see it or not? Anyways, it's just the cells. You take x square. You know, my cell I'm calling it C7. So I got C7 times C7 times negative 1 plus 3 times C7 plus sine of C7. I had to add some stuff here to convert it into radians. I added a pi times 180. I'm going to show you guys this. Let me see if I can zoom in there. No. Control. Yeah. Oh yeah, baby. Can you see it now? There it is. That's what I have. Alright, let's get back to normal size. Alright, and so then I plugged it in there, and that gives me my next x. But here's what the thing. For that one, I'm going to say that's equal to, I'm going to call it this cell. Bam. And it auto-populates my next x value. And then I'm going to do the same one. I'm going to call it this one. That one, that one, that one. So it's pulling this number and putting it here and then computing it. And in this way you can get, you know, hundreds of approximations just like that. And so we solve this is roughly 3.01747 blah 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 blah. See how nice that is? That's how I roll. That's why they pay me. That was fun. All right. So anyways, you know, you can't learn all this by watching the hands. As much as I would like for that to happen, we all would like, but really you have to practice it yourself. You've got to do the homework, sit there through the homework, and then struggle and make it your own ideas. Okay, I think